Sorry about the abrupt stop. The videos are given a 15-minute max, and so I'm going to try to start back where I stopped last time. And that's not where we were. All right, we were here and we were talking about um, the supply and demand curve. And what we said before was that our supply curve is this curve right here, which is an increasing curve. And we explained that suppliers wanted to sell a higher quantity, right? They would rather sell 1,000 or 4,000 at this high price of, let's say, almost $125 versus selling a low quantity like 1,000 at a price of, let's say, $12 or $13, right? But specifically, we're asking here at a price of $50 per item, the suppliers will supply, well, $50 is here. And on my curve, my supply curve, I get this point right here, which, if I can draw this, is about 2,500, maybe 2,450. That point may be the point 2,450. And so we can say that suppliers want to supply about 2,400. Now, some of you may say that that's 2,300 or 2,350 or 2,450 or that's actually 2,500. All of those are in the vicinity of where the answer is, and so those are all acceptable. So this can vary. All right, and so if you are working with one of your classmates and your classmate says 2,350 and you say 2,400, I would accept both of those. Because we don't have the actual equation here, and so we're looking and we're kind of estimating that way. Okay. Part C, why is the demand curve decreasing as you move to the right, right? So our demand curve is given over here. It's the decreasing curve here. And I'm doing a horrible job of drawing over that. And it's decreasing because people don't want to buy a product at a very high price, right? And so that's why you see for these low quantities, like 100, 200 quantity of items at this very high price of over 75, between 75 and $100, not a lot of people want to actually buy that. But as the price decreases, the number of people who are willing to buy the product actually increases, all right? So as price increases, the demand decreases, okay? And that's why we have a decreasing function here. Part D, a price of $50, so we have the same $50 here per item. What will consumers be willing to buy? Well, like before, I'm going to go where y equals 50. I'm going to find a point on my graph. And this one's pretty nice here. It's not much of an estimation here. But this point right here seems to be the point 1,000, 50. If I go down there, I get to 1,000. And so consumers will be willing to buy 1,000 items. All right. Part E, it says if the price is $50 per item, what would you predict about the future price of the good? Explain your answer. All right. Well, marked in the graph, even if this was not marked in the graph, we would be able to figure this out. But this point right here where supply equals demand, that is our equilibrium, right? And we always know that our market wants to settle at equilibrium. Well, right now, at $50 per item, right, we are above equilibrium. Equilibrium is down here. At a price of 50 items, we're up here. So the prices should go down so that we'll be at the price of equilibrium, right? So the market should, the future price of items should be lower than $50. All right, that's going to be the future price of the good. All right. You can also think of this if you don't want to look at the graph necessarily. You can look at these two answers here, right? We know that our supply was 2,400 approximately, and our demand was approximately 1,000 items. That means supply is greater than demand. 2,400 is greater than 1,000, which means we have a surplus in the market and not a shortage, right? Whenever there's a surplus in the market, that means that we need to drop our prices so that people will buy more and more of the product. There's just too many items on the market. All right. And so that's the last answer there. Okay. So that's problem 14. Another problem that I want to look at is problem 21. All right, it says the graph below shows exponential growth of the population of a town. Estimate the doubling time of the population. Every single example that I did in class that dealt with double time, half time, triple time, any kind of time like that, we looked at the actual function. This is asking us to do the exact same thing, but looking at a graph. Right? Remember, doubling time is the amount of time it takes us to get to twice the quantity. And I guess I can be a little specific here. Twice the quantity. I'm going to leave it there. Twice the quantity, right? And so if I look at my graph, I can choose any point. I'm going to choose the easiest point right here, right? This point right here is our initial quantity, right? Our initial quantity is 1,000 people. That is our initial quantity. If I want to know the double time, then all I have to do is look at how many years it takes me to get from, to 2,000, right? If my initial quantity is 1,000, my double time, my double of the quantity will be 2,000, which occurs at this point. And the amount of time it takes to go from initial to this amount, 1,000 to 2,000, is 4 years, right? There isn't any work to show here. There we go. And the interesting thing about this is that I didn't have to use this initial point. I could also use the point for 2,000 here. And for me to double 2,000, I would have to get all the way up to 4,000, and that occurs here, right? And the amount of time it takes me to go from there to there, well, 8 minus 4 is 4 years, right? And so our doubling time is 4 years, all right? In parentheses, it says be able to find the half-life from the graph, right? Half-life occurs when we have a decreasing function. And so you would do basically the same thing, but you want to see how long it's going to take it to get to half, all right, instead of double, all right? Those are the problems specifically from the worksheet that I posted on Blackboard. I didn't want to go through many of these examples because I want you guys to work them out yourselves, all right? I do, however, want to look at an example that I got questions about on the homework. I got at least 1 or 2 questions about this one. It's either in section 1.6 or 1.7, but there's an example that has B equals PE to the RT, and it says to solve, and I'm going to put a number here. Let's put 3RT. And then what we want to do here, put a comma, I'm going to solve for, let's say I solve for T, for instance. So I'm going to solve this equation for T. Now here, we don't have a lot of numbers here. We just have a bunch of variables and then one constant there, 3. Although these variables are constants too. All right, but if I want to solve for T, notice where the T is. Our T here is in the exponent, right? And if I want to solve for something, a variable that's in the exponent, I'm going to use my natural log. Now, if you want to use a different log, just as I stated in class, by all means, you can do that, right? But in this example, I'm just going to use the natural log, okay? And so in order for me to use the natural log to get this T out of the exponent, the first thing I'm going to do is I'm going to isolate this expression e to the 3RT, right? To do that, I'm going to divide both sides by P. Okay, and so this left-hand side is going to stay B over P. Normally when we have numbers here, this B over P will be like a decimal or something, all right? It could be a whole number. But since we have only variables here, I'm going to have B over P there. Now I'm going to take the natural log of both sides. And if you notice, by our rule that ln of e to the x equals x, just that exponent there, we can apply that to here. I'm going to go ahead and write this as e to the ln of e to the 3RT. And by using this rule here, I'm going to get ln of b over p equals 3RT. Okay? Now, in order for me to solve for t, I divide both sides by 3r. And I'll get that t equals that same thing that I have here. Nothing can cancel. I'm completely simplified. Now you could separate that with a subtraction and do ln of b minus ln of p, but that is not necessary. It's good to just leave your answer in this form right here. Okay? And so that's what I'm going to do here. My final answer here is t equals ln of B over P, and that quantity is divided by 3R. All right, and so that concludes what I wanted to review. Of course, as you are reviewing for your exam, definitely look at the review problems on that sheet. Look at your old quizzes. There are 2 of them. Look at that homework worksheet. And look in your notes and your homework assignments. All right. If you had issues with any homework problems, right, make sure you review those. All right. When I make your test, I try to make sure that I give you items that are sort of similar to what we've done in class or what you've done on your homework. All right. And so don't just study the review problems. Make sure you also review these things as well, and it'll help you be more prepared for your test. I recommend that you attend SI, the review session for SI. If you need help, make sure you send me an email, and I'll try to respond to you in a timely fashion. But good luck as you continue to study. I will be posting a video with the solutions to your quiz 2, and so study both quizzes, but I'm going to put the solutions for quiz number 2 on Blackboard, as well as the worksheet that you guys submitted. All right, and this concludes this video.